Hello, we are on day 2. The first problem of day 2 is 2-sum, and here we go. Alright, so continuing on, this is the logic for let I equal 0, I less than nums dot length. We're gonna search every element here, and we're gonna say, hey, the one that I want is a pair, which is target minus nums at current position. That's the one which added to nums will give us target. Okay, and if the target is in pairs, then I return the indice of this one. They do it in order, so why don't we return the not target, pair. If pair in pairs, return the pairs pair. So hence the indice of the pair and the current index, which is I. Else, we're going to add pairs of nums at I to equal I. And we are guaranteed an exact solution, so this is not required, but let's say this just in case. So at this point, if we are starting from here, we're starting from 2, I is 0, I is over here. Pair to this one is target 9 minus the num at 2, which is 7. And pair is not yet in pairs yet, so we add the pairs, the nums at I, which is 2, to equal the current index position, which is I, and we continue. Alright, now we're at 7. Here we check, is the pair, which is target minus 7, which is 2, in pairs? It is, so we return the nums at I. We return pairs at pair, which is 2. That's index position along with current index position, and this should work. Running the code. O of n. Yes, I've done this so many times. Oh, okay, not dozens. Well, anyways, O of n, I would say time is O of n, because at most we iterate once through the array of nums, and space at most will be O of n as well, because at most we will generate a map of that many values. Alright, that is the first data structure in day 2 with concentration in arrays. Let's refresh. The next problem is merge sorted array. Let's start now. Alright, so merge sorted array. You were given 2 integer arrays, nums1 and nums2, sorted in non-decreasing order. So that probably indicates that they are sorted in either increasing or there could be duplicates. And 2 integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted also in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Alright, so it's pre-filled for us. Input, we have this, and let's see. Let me write it here this time. Alright, so nums1 is this, nums2 is this. As we can see, the m is that many values here, n is that many values in the second array, and it's pre-filled to 0, so nums1 is this. I'm trying to see, what can we do? We are merging in non-decreasing order. So for the indices, we have this. All right, I'm thinking we can iterate. We have 2 pointers. So we have the current pointer, which is, let's say, C. And we have the insert pointer, which, let's say, insert next pointer, which is N, let's say. Cur position, let's say, is C. All right, cur position starts at 0. Insert next position starts also at 0. What do we do? One thing I could say is, how do we solve this? We have 1, 2, 3, 2, 5, 6, and we have to do this in place. So probably some swapping going on. You know, I'm thinking because we know the size of both, why don't we do it backwards? As in, we can fill up the last part. So instead of iterating from 0 to the end, we can actually iterate from current position will be different each time, but the insert next position will start at m plus n minus 1 because it is 0 index. So that'll be the next insert position, and then